let's try number 15. So, for number 15, we're looking for a pattern. And to find this pattern, we're going to start looking at powers of 7. In other words, 7 raised to some power. And we want to see, does a pattern arise specifically with the units digit, or the ones digit. So 7 to the 0, in case you don't know, is going to be 1. And anything to the 0 power is equal to 1. 12 to the 0 power is equal to 1, for instance. Okay, so if you never knew that before, it's true. Anything raised to the 0 power is by definition 1. What's 7 to the first power? Well, that's just 7. What about 7 squared? Ooh, I know. It's 49. Now, it's specifically the ones digit that we're interested in here. So I'm going to underline the 9. And what about 7 to the third power? That's 343. Okay, but it's the 3 that I'm interested in for this problem. And so far, I don't really see a pattern necessarily. I see some different numbers. Let's keep going. 7 to the fourth. Would be 2401. So it's really this last number that I'm interested in. And you notice, this is the first time I get a repeat. So let's see if this helps us find our pattern. What about 7 to the fifth? 7 to the fifth. It ends in a 7. Okay, so it looks like maybe we're starting a pattern here. So 1, then a 7, then a 9, then a 3, then a 1, then a 7. So I bet 7 to the 6th. I conjecture that it ends in a 9. Hey, look at this. So 7 to the 6th equals blank, 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 9. It ends in a 9. That's the units. And so I might conjecture that 7 to the 7th ends 1793. 179 and a 3. Let me test that conjecture. Hey, it does. Okay. And then 1, and then 9. So, sorry, 7. 1793. And we might expect that that pattern just continues on and on forever and ever. And if you're wondering, it does. Okay. So how would this help us find the last digit, the ones digit of 7 to the 101? Basically, we need to figure out where that would fall in this pattern. Would it be the first one? Would it be the second one? Would it be the third one? Would it be the fourth one? And then the pattern starts over. So what you might notice, we start at 0. That's where our pattern starts. I'm going to put a box around it. And then our pattern starts over at 7 to the 4th. And then we would see our pattern start over again at 7 to the 8th. So because our pattern has a length of 4 different numbers, and then it starts over, all these numbers are going to be a multiple of 4. So 7 to the 0, 7 to the 4th, 7 to the 8th. This is where our pattern starts over. So likewise, it's going to start over at 7 to the 12th. Equals something ending in a 1. And then we're going to have a 7, a 9, and a 3, and then 7 to the 16th. It's going to end in a 1. So you notice that these are all multiples of 4. That's where our pattern starts over, at least at 1. And so let's try and work backwards. What's the nearest multiple of 4 that's close to 101? Well, it's 7 to the 100. So because it's a multiple of 4, we can safely assume that, just like these other multiples of 4, it's going to end in a 1. Did anybody try typing it into their calculator? So, in case you're not familiar, this is times 10 to the 84th. And that means there are 84 digits after where it shows the decimal that are actually part of the number. So you can't even see the last number. You can't see the last digit because it would be 84 places away from this decimal. It would be way off the screen to the right. So, because this is a multiple of 4, we're going to assume our pattern is going to start over at 7 to the 100. So what comes after a 1? A 7 does. So 7 to the 101 is going to end in a 7.